this is a massive issue. We see a lot of people do some really quite bizarre things in sleep. People who have cooked meals in their sleep or eaten food that actually they shouldn't be eating, pet food, or vegetarians who have eaten meat in their sleep. I remember seeing one young man who jumped out of his attic and fractured his pelvis and his legs. And then of course the real extremes are those individuals who commit sexual assault, people who have murdered somebody.
Guy, great to see you. What sparked your initial fascination with sleep and led you to focus your career on it?
Well, I was always fascinated by how the brain works. What astounds all neurologists and neuroscientists is how this lump of fatty tissue, which sits within our skulls, defines every aspect of our being, from our personality to how we move to how we experience the world. And yet, when it comes to sleep, which we spend about a third of our time doing, so little, particularly when I started out, was known about what sleep does to the brain and how the brain controls sleep. So that was where it came from, really.
So how did you transition from general neurology into the specialised field of sleep medicine?
Well, most of us train in general neurology and subsequently find subspecialties. So I have colleagues, for example, who specialise in MS, others who specialise in epilepsy or headache. And, I was very fortunate because for some of my training, I spent time at the hospital where I currently am, which is St Thomas's Hospital in London. And we were very fortunate there to have a colleague who had been one of the early adopters of sleep medicine and had gone to Los Angeles and trained in Los Angeles and brought his expertise back. So I was exposed at quite an early stage in my training to sleep medicine as a concept. And, it was really seeing these patients and the fascination of sleep generally that triggered my interest and allowed me to pursue that training in a more specialised area of neurology.
You mentioned the patients. What kind of patients or research topics first made you realise how little we understand about sleep?
Well, I remember very early on in my medical career, in fact even before I was qualified as a doctor, we in medical school at that time had, I can think of no single minute of training when it came to sleep. And yet when I was doing many medical students, when they go through medical school, they undertake something called an intercalated degree. So you do your 5 years of medical training, but you also spend a year getting a BSc, a bachelor's. And I chose to do a bachelor's in neuroscience, unsurprisingly, given what I've told you. But one of the modules was to try and understand what sleep and dreaming was about. And the papers at that time were really rather speculative. We had very little inkling about what was going on, and it was all theory. And it made me realise quite how much there was to learn about sleep.
So could you share a bit about the major sleep centre that you ran? I mean, what happens there on a typical night?
Well, the sleep centre that I still work in is based at Guy's Hospital, which is right next to London Bridge train station. And in it, we obviously have a lot of clinic rooms, but the main activity is in the sleep laboratory. And the sleep laboratory consists of 10 separate bedrooms, and we admit patients into the sleep lab. We monitor their brainwaves, we monitor their breathing, their heart rate, their movements. We video them in order to get a very accurate view of what their sleep issues are and how to solve them. So we're doing about 50 to 60 sleep studies every week.
How many sleep studies have you done in total?
Well, I think, we can sort of roughly work it out. If we're doing about 3,000 studies a year, and that sleep centre has been going at that kind of pace for at least 10 or 15 years. So we're talking about many thousands.
What's the most surprising trend that you've noticed from these sleep studies?
Well, I think that there are several trends. I think what we begin to realise is how different sleep is for everyone. Obviously what we're doing is we're doing these sleep studies on individuals who have significant sleep complaints. It's very rare that we would do a sleep study on somebody who doesn't have any sleep issues. But what you see is a huge variation in terms of how much sleep people get, what stages of sleep they go into, and also the sorts of pathologies of sleep, those disorders of sleep that we see. In terms of general trends, it's a little bit difficult to unravel what is as a result of societal change and what is as a result of the fact that actually people are much more aware of sleep in general, because obviously podcasts like this and the media generally has shifted quite a lot in terms of its attention on sleep, and therefore how much of it is related to the fact that people in their increased awareness are more readily coming forward to their doctors to say, hey, hang on a minute, I think I've got some sleep issue.
Interesting. So what other trends have you noticed from your sleep studies?
Certainly after the pandemic, we saw a big spike in people who were complaining of insomnia. And certainly now some of that I think is perhaps directly related to COVID and long COVID. Some of that is related to the societal changes that occurred over the pandemic as well. People's moods deteriorated, they became more anxious, there was social isolation, and this had a huge impact on people's sleep.
What defines healthy sleep? Is there a certain number of hours that people need each night, or does it differ for every single person?
Well, there's huge variation in terms of what constitutes a good night's sleep. So, this idea of 7 to 8.5 hours, I think, is probably correct on a population basis. But we know that a lot of people sit outside that window and don't have any sleep complaints and have very normal sleep. We know that genetics is important, so there are, for example, rare genes that allow people to sleep for 4 or 4.5 hours without any negative consequences. Now that's rare, it's worth stressing that, but also there are some genetic variants that define very clearly how much sleep you need. It's also influenced by how old you are. So as we get older, particularly in the transition between adolescence and adulthood, the amount of sleep we need substantially reduces. And it's also a function of the quality of your sleep. So whether or not you've got any sleep pathology, like, for example, problems breathing at night, or neurological disorders that influence sleep quality, that are going to ultimately define how much sleep you need. So as a rule of thumb, if you're going to bed at the same time and waking up at the same time every day, and you're waking up feeling refreshed and you're ready for bed the following day, then you're probably getting the right amount of sleep for you.
And how about things like deep sleep and REM? Quite a lot of the sleep trackers track those two metrics. How important are they, and how much of a role do they play in restoring the body and the mind?
So this is a controversial area. I think the first thing to say is that sleep trackers are very variable in terms of how well they define those sleep stages. And even if they are one of the better class of devices, they are validated in people who sleep normally. They're not validated in people who've got anything else going on with their sleep. So I think one has to take the data that sleep trackers produce with a pinch of salt. But as a general rule, deep non-REM sleep, so that is what we used to term non-dreaming sleep, although it's a bit more complicated than that, is the stage of sleep that we most associate with restoration of function, with regulation of our immune system, with housekeeping of the brain, whereas REM is probably more important when it comes to things like memory and regulation of our emotions. Although it's probably the case that it's the cycling between non-REM and REM sleep that is really important. So clearly, if you are getting very little deep sleep, very little non-REM deep sleep, then that is going to have an impact on how refreshed you feel, and may well have some broader impacts on your physical and psychological health. But actually, it's yet to be determined that a reduction in REM sleep has any long-term consequences, particularly as we get older. In the olden days, there were drugs that used to be used fairly widely as antidepressants that abolished REM sleep completely. And it was not entirely obvious what the consequences of that was.
How about the effects of alcohol on a night's sleep?
I think alcohol is pretty horrible for sleep. Obviously, it's a sedative, and so it may help you get off to sleep. But we know that alcohol disrupts sleep generally, so people tend to have much more frequent awakenings when they have had significant alcohol. That it worsens sleep apnea. So sleep apnea is this breathing issue where your airway collapses and it disrupts your sleep, which is why a lot of people say, well, I only snore when I have a few beers. That snoring is related to the fact that the airway is narrowing. Having a full bladder at night is also not good for your sleep quality. And we know that alcohol can also, if you have a tendency to, for example, sleepwalking or night terrors, can make these much more likely to occur. So generally speaking, alcohol is a very bad thing for sleep all round.
That's a shame. That's a real shame, that. Can you explain in simple terms the importance? Can you explain in simple terms the importance of our circadian rhythm?
All organisms on the surface of the planet, all living organisms, within them have a 24-hour clock, which is termed our circadian rhythm. And that 24-hour clock regulates a range of functions, even within single cells. Now, in humans, we have a master clock that sits deep in the center of the brain, in an area of the brain called the suprachiasmatic nucleus, which is the major regulator of other internal clocks within our organs and within our cells. And so pretty much every process that is undergoing within our bodies themselves, so be it from metabolism to behavior to how our gut functions to how our liver processes the metabolites that are as a result of the breakdown of what we eat, and of course importantly our brains, is under this 24-hour cycle. So anything that disrupts that 24-hour cycle can have significant impact not only for our sleep but also a range of other processes that are going on within our bodies.
And why is light, especially blue light, such a powerful regulator of our internal body clock?
I think the obvious answer is, the purpose of having a body clock is so that we can maintain our biological processes in line with sunrise and sunset. Now, from an evolutionary perspective, that makes perfect sense. And the way that in the human body that has arisen is that there are cells in the back of our eyes and our retinas that are not involved in vision at all, that are simply there to collect information about the intensity of blue light in particular. And those cells that are called retinal ganglion cells, they have projections directly to this small area of the brain called the suprachiasmatic nucleus, and so help regulate the circadian clock. Now obviously, because sunrise and sunset changes, because we live on an earth that has a summer and winter, our circadian rhythm does need to be adjusted a little bit, and that's how we respond to changes in natural light.
I've got a pair of these circadian rhythm adjusting glasses. So when you fly west, you sort of put these things on, it zaps you with blue light, and it's supposed to enable you to acclimatize to the new time zone. Do you think that sort of thing works, or again, is that just a clever sales pitch that I've fallen for?
No, you're not just being gullible, Chris. This is so. We know that by manipulating exposure to light, we can push people's circadian rhythms forward or back. And in fact, we use this in clinical practice because we often see individuals who have a change in their circadian clock that results in them going to sleep very late and waking up very late. So occasionally I see individuals who can't go off to sleep until 7 or 8 a.m. and then wake up 7 or 8 hours later. The converse is also true, whereby we occasionally see people who fall asleep very early and wake up very early, although that's much rarer. And in those individuals, what we term circadian rhythm disorders, we will often use lamps that simulate sunlight in order to manipulate their circadian rhythm. But it's important to know that depending on when in relation to your circadian rhythm you are exposed to that light, it can have very varying effects. So if you give somebody light at the wrong part of their circadian rhythm, you can actually push them in the opposite direction to what you want them to shift in.
And how do I know which part of my circadian rhythm that I'm in?
Well, I think that depends on what your natural bedtime is, what your natural waking time is, what direction of travel you're going, whether or not you're going east or west, and how many time zones you're going in. So it's not a straightforward thing to do. Certainly if you are traveling west and you want to delay your circadian rhythm, so you want to go to bed later in order to sync more quickly with, for example, going to the west coast of the United States, then exposing yourself to bright light at a time where you would normally be wanting to go to sleep will help delay your circadian rhythm.
So I'll keep zapping my eyeballs with these glasses around 11 p.m. UK when I'm traveling to the US. Then okay, that
Yes.
sounds good. Let's talk about insomnia then. What are the main causes of insomnia, and how do they differ from mere lack of sleep?
Insomnia is very different from sleep deprivation. So sleep deprivation is basically when people are basically burning the candle at both ends. So they're not giving themselves enough time to sleep. But when they do get into bed, they can fall asleep quickly and they will sleep until whatever it is wakes them up. Whereas insomnia is a different entity completely, both in terms of what individuals complain of and also in terms of what the resultant changes within the body are. So insomnia is not the fact that you can doze off whenever you go to bed, but you're just not giving yourself enough time. It's the fact that actually you feel tired, you want to go to sleep, and you're in bed, but either you can't drift off to sleep, or you can't stay asleep, or you have really rubbish quality sleep overnight and wake up feeling tired and unrefreshed. So there are other differences between insomnia and sleep deprivation in that if you are very sleep deprived, the likelihood is that if you're given the opportunity to sleep even during the day, you're going to be able to doze off. Whereas for people with insomnia, the same process that's going on at night is also active during the day, and therefore, a lot of people with insomnia will say, well, I only slept 3 or 4 hours last night, but if I try and nap during the day, I won't be able to. I won't be able to fall asleep. And actually, we see differences in terms of chemicals and hormones between people with insomnia and sleep deprivation. For the vast majority of people with insomnia, actually, the total amount of sleep that they have is not significantly shorter than the average individual. A lot of the time it's about the perception of the quality of sleep, and we know that actually that when we objectively measure sleep, it's often quite significantly different from the subjective experience of sleep. We're rather poor witnesses to our own sleep. And so many of the health concerns that are all over the media about the risks of sleep deprivation, they're absolutely right, but they don't apply to the vast majority of people with insomnia.
Was what you said, insomniacs probably have as much sleep as the normal person, but they just don't think it's as high a quality.
Yeah, so I think there's a subgroup of people like that. So, undoubtedly, most people with insomnia get very slightly less sleep than a normal individual, but the differences are not huge for the majority of individuals. So a lot of the time it's about the perception of sleep. We sometimes see something called paradoxical insomnia, where people will say, well, I didn't sleep at all last night, and yet when we bring them into the sleep lab, we record 8 hours of great quality sleep. So I think that highlights the fact, again, that we're not particularly good witnesses to our own sleep. There undoubtedly is a subgroup of individuals with insomnia who, when we record their sleep, have a very, very short sleep duration. And for those individuals, those health risks that are associated with sleep deprivation are real. But for the majority of people with insomnia, that's not the case.
That's incredible that it's all about perception.
We tend to think of the brain as being either awake or asleep, or in non-REM sleep or in REM sleep. What we actually know is that different parts of the brain can exist in different stages of sleep or wake, or indeed different stages of sleep. And there is some evidence that for people who have paradoxical insomnia, this concept of actually getting really decent sleep but feeling like you haven't slept at all, that when we look at areas of the brain that we think are involved in awareness, in consciousness, they don't enter into sleep in the same way as the rest of the brain is. So whilst the rest of the brain may be very deep asleep, actually the bit of the brain that is responsible for your awareness might not be entering into deep sleep, which can give you the perception that you haven't slept very well at all.
Interesting. So how do you decide whether someone needs therapy like CBT for insomnia, or a medical test like a sleep study? How do you decide?
Well, I think that it's important to stress that not everybody with insomnia needs a sleep study, because, essentially, if you're already having trouble sleeping and you come into the sleep lab and you're covered in wires and you're in a strange environment on a dodgy hospital bed, the likelihood is you're going to get a really, really bad night's sleep, much more affected than it is at home. And so if there aren't features of other sleep pathologies that we need to address, if it's not a case of we think that actually there is something biologically wrong with that individual, then we probably won't do a sleep study in those individuals with insomnia.
So then, is it cognitive behavior therapy? Is that the easiest choice?
Well, I think it depends on what people have tried before, but certainly, there's been a big sea change in the last few years away from treating people with insomnia with drugs. A lot of these drugs have potential issues with them, so they often work well in the short term, but they often tend to wear off. Some of them are associated with dependency. Some are associated with, for example, an increased risk of accidents during the day because of the sedation associated with them. And in the long term, there are increasing concerns that some of these drugs may actually contribute to cognitive decline later on in life. And obviously that's a really major concern. So over the last few years, there's definitely been a move away from prescribing of drugs for insomnia towards the treatment of insomnia using non-drug based methods. And the most popular non-drug based method, the one for which there is the most evidence for, is that treatment that you mentioned, which is called CBTI, which aims to restore people's normal sleep patterns.
So what does that involve? Is it meeting someone once a week and having a conversation about their sleep, or is it something more than that?
It's a little bit of that. It is meeting somebody once a week, but it's also about putting in place exercises that rebuild your brain's association between bed and sleep. So a lot of people with chronic insomnia, their brain on a conscious and unconscious basis associates their bed with being a place that is where they spend time awake, and it's often a place where they feel agitated, where they feel frustrated, where they feel anxious. And it becomes a bit of a self-fulfilling prophecy, because if that's the association your brain has with bed, then that's what will happen every time you get into bed. Whereas what CBTI aims to do, it aims to break down those negative associations between bed and sleep and rebuild positive associations. Some of that is through talking, but a lot of it is about changing your sleep habits. So one of the really powerful techniques that is part and parcel of CBTI is actually asking people to restrict the amount of time they spend in bed. Now that sounds torture to people who have got insomnia, because all they want to do is spend more time in bed to give them a chance to catch up. But for most people with insomnia, what's happening when you do that is you're spending more time either awake before you drift off to sleep, or more time in the middle of the night awake, and you're then strengthening that negative association. Whereas by reducing the amount of time you're spending in bed, you're actually rebuilding that association, and with a bit more sleep deprivation, you then strengthen that association further, because when you're very sleep deprived, you're much more likely to drop off to sleep more quickly and stay asleep.
So go to bed only when you're really, really tired, and then if you wake up and it's a reasonable time, say past 5 a.m, move out of bed immediately would be the best way of thinking about it.
Well, I think that's a sort of a simplified way of doing it, but obviously, if you've got really bad insomnia, you probably need a bit of help. But I think that there are some hard and fast rules that you should probably follow, which is if you've got into bed and you're not asleep within 20 minutes or so, you should probably leave the bedroom, because it's about associations not just with your bed but also your sleeping environment. Go and do something relaxing that doesn't involve exciting stuff that is going to agitate your mind. Avoid something that is going to expose you to very bright light, so things like reading or listening to music, for example. And then when you feel sleepy again, try and go back to bed and see whether or not sleep happens. The same in the middle of the night. A lot of people with bad insomnia will lie awake for hours at night in bed. And what happens when you do that? Well, your anxiety increases, you get more annoyed at the fact that your partner's snoring next to you, you get more worried about the fact that you've got to function properly the following day to perform at work or to fulfill your family duties. It's not conducive in the long term to actually restoring normal sleep patterns.
I think it's definitely got harder in the last few years. So it'd be good to talk about the modern world and the lifestyle factors. So how does all of the stress, all of the screen time, everyone's addicted to their phones, all of the late night work sessions, how does that disrupt the sleep patterns?
Well, I think none of that has been good for sleep. It's basically, what's happened over the last few years is that work and pleasure or leisure time has made its way into the bedroom. And both of those have weakened the association between your bedroom and sleep. It's probably worse than that because a lot of us are spending a lot of time on electronic devices in the bedroom, and we already talked about the effects of blue light on your circadian rhythms. And so regular exposure to computer screens, to laptops, to mobile phones is probably, in some of us who are susceptible to it, causing a shift in our circadian rhythms and making it more difficult to get off to sleep. There's also all the mental agitation of spending any time at all on Twitter at night or any of these other social media platforms, because it's not just about exposure to light, it's also about getting you in a frame of mind where you're relaxed and ready to go to bed. And certainly a lot of posts that I read on social media are very far away from anything that's particularly soothing.
Absolutely. What impact does diet and exercise have on the quality of sleep?
We know that exercise, generally in all forms, although possibly slightly better for sleep is aerobic exercise, can improve the stability and the amount of deep sleep that you're getting. Generally speaking, we tend to recommend that people don't exercise intensively in the hour or two before bed, because obviously you're activating your system and that's not particularly good for sleep onset. Diet, well, certainly diet has a weak effect on your circadian rhythm. So we know that our circadian rhythm is influenced by what time we are eating. Large carbohydrate-rich meals are probably not good for sleep on a number of levels, because people can get a little bit of reflux at night if they've eaten a large meal just before bed, and it can sometimes cause some shifts in your blood glucose levels overnight, which can destabilize sleep. So there are some precautions that you need to take. Look, ultimately, Chris, it comes down to the fact that there are many people who can eat a huge plate of pasta before bed and sleep like a baby. So none of these rules apply to every single person on the planet. It depends very much on what your susceptibility to sleep disruption is, and whether or not these kinds of factors are going to have a direct bearing on the quality of sleep that you have.
You touched on sleep apnea earlier. How big a factor is weight gain in conditions like sleep apnea, and can losing weight help reverse it?
Yeah, so this is a massive issue. We know that sleep apnea is certainly very strongly associated with weight gain. That's probably one of the reasons why we think sleep apnea has become so much more prevalent in today's society. It's important to say that just because you're skinny doesn't mean you can't possibly have sleep apnea. I often see people who are very, very thin who have significant sleep apnea, but certainly weight gain is a very, very strong risk factor for developing significant sleep apnea, and weight loss can help improve your sleep apnea. In fact, weight loss can be, for some people, can be a cure for sleep apnea. So certainly if you're snoring very loudly, your sleep is being disrupted by choking or gasping, your partner has noticed that you're stopping breathing at night, and you're waking up feeling unrefreshed and dozy during the day, then if you've gained a few pounds, then certainly trying to lose those may well actually cause a resolution of your sleep issues.
Let's talk about parasomnias and extreme cases. Could you describe some of the more extreme parasomnias, like sleepwalking or acting out dreams, or?
Yeah, actually, this is one area where we see a lot of people who do some really quite bizarre things in sleep. So, I've seen people who have run themselves a bath and got into a bath in their sleep. People who have cooked meals in their sleep or eaten food that actually they shouldn't be eating. Occasionally pet food or things like that, or vegetarians who have eaten meat in their sleep. I've seen people who have driven or ridden motorbikes in their sleep. And at the extremes, I've seen people who have either caused themselves or the people around them really significant harm. I remember seeing one young man who jumped out of the skylight in his attic apartment and fractured his pelvis and his legs as a result of jumping out of the window. And then, of course, the real extremes are those individuals who commit acts that are potentially criminal acts in their sleep. So people who have committed sexual assault, and in the literature, people who have murdered somebody. Now, I've seen a few people who claim they've murdered people in their sleep, but never convincingly.
What's the scientific explanation behind these actions then?
So parasomnias come in two major forms. The first is out of REM sleep, and that's called REM sleep behavior disorder. So these individuals tend to be acting out their dreams. Now, normally when we're in REM sleep, we're completely paralyzed. We can't move at all. The only muscles that continue to work are the muscles that allow us to breathe, and the muscles that move our eyes, which is why it's called rapid eye movement sleep. And in these individuals, that mechanism of paralysis doesn't work properly. And so particularly with very strong emotionally laden dreams, they will often act out. So these dreams will often be about attacking somebody or protecting themselves, and they'll lash out in their sleep. Now, the other type of parasomnia is something called a non-REM parasomnia, which arises from very deep sleep, and these are the ones that we're much more worried about, because these are the sorts of parasomnias in which people can get out of bed and can leave the house, can climb out of windows, can drive, all these things that I talked about. And these non-REM parasomnias have a slightly different basis, because I already mentioned a little bit how we think that different areas of the brain can exist in different stages of sleep. What we think is happening in non-REM parasomnias, and we have quite a lot of evidence to suggest this, is that different parts of the brain remain in very deep sleep, whilst other parts of the brain actually demonstrate waking activity. And so the parts of the brain that demonstrate waking activity are areas of the brain that are responsible for emotion, which is why these kinds of events often have a strong emotional component to them, and parts of the brain that are involved in movement and vision, whereas the parts of the brain that remain in very deep sleep are the bits of the brain that are involved in memory, which is why people often don't remember these events, and also, importantly, the frontal lobes, which are the bits of the brain that sit right over behind the eyes. And that part of the brain is really responsible for planning, for rational thinking, for reasoning. So if you imagine that the part of your brain that's responsible for rational thinking and reasoning is asleep, whilst the rest of your brain is awake, that can result in some rather bizarre behaviours.
So how do legal systems handle cases where somebody claims they were sleepwalking?
Yeah, well, I mean, this is a really, really difficult area of forensic medicine, because the only way you can be absolutely sure that when somebody committed a particular act they were asleep is if you had electrodes attached to their scalp at that time, which is untenable. So we really have to pull together evidence from a number of different strands. So whether or not this individual clearly had an established pattern of sleepwalking before the event, whether or not there was any planning that was associated with this particular act, whether or not they did anything to hide the fact that they'd undertaken this act, but also there are a number of other features that we would look for to try and satisfy ourselves that this particular event could be representative of a non-REM parasomnia or is not consistent with it at all.
Are certain people more prone to dangerous sleepwalking because of their genetics or stress in their life?
We know genetics is a very strong component. So, a lot of people with non-REM parasomnias have a family history of non-REM parasomnias, about 50%. So genetics is important. We also know that anything that destabilizes sleep, so sleep apnea, for example, or other conditions, can result in these partial awakenings that arise from sleep. There are also certain drugs that can increase the likelihood of sleepwalking events. Of course, look, as children, many of us will have night terrors, which are a form of non-REM parasomnia. Many of us will sleepwalk. But actually, for it to persist in adulthood is much rarer. It's about 1 or 2% of the adult population. Now, 1 or 2% is still quite a high number of individuals who have these kinds of events, but fortunately the ones that are really dangerous are pretty rare.
Is there a difference between night terrors and nightmares?
So nightmares arise from REM sleep. So these are dreams, usually of a narrative structure, that have a narrative that have a negative emotional content to them. Whereas night terrors are usually snippets of experience, what we term non-REM dreaming, which are little visual vignettes or feelings of threat that are associated with acting out, and they arise, as I said, from non-REM sleep. So although people often use the term nightmares and night terrors interchangeably, they are actually quite distinct entities.
What function does both of those serve, if any?
Well, I think they're probably just a glitch. So, particularly non-REM parasomnias are a glitch in how our brains work and how our brain activity is regulated. When it comes to nightmares, we know that for some individuals, particularly those who've undergone traumatic experiences, recurring nightmares are often a very strong feature, and those recurring nightmares often have an association with the trauma that they've experienced in their lives. And so what we think is happening is that normally when we dream, one of the functions, and it's to be stressed that it's probably only one of the functions of dreaming, is to reduce the emotional content of any particular experience that we've had. But in nightmares, if the emotional content is so high that it actually wakes you up, then that process is never completed, which is why they often tend to be recurring in people who've had significant trauma associated with those nightmares.
Is there a link between poor sleep and neurodegenerative conditions like Alzheimer's disease?
Yeah, I think there is quite a lot of evidence to suggest that poor quality sleep may increase your risk of conditions like Alzheimer's disease, although it's rather difficult to be 100% certain. Certainly we see that insomnia is a risk factor for developing things like Alzheimer's disease, although there are a number of potential explanations. The first explanation is that actually in the prodrome to Alzheimer's disease, sometimes many years earlier, you might be at increased risk of insomnia. The second explanation is that, look, there may be shared genes between Alzheimer's disease and insomnia that put you at risk of both. The third is that actually some of the drugs that historically have been used to treat insomnia might in themselves predispose to these conditions. But the fourth is that actually insomnia does predispose to Alzheimer's disease, and there is some rationale as to why that might occur, because what we know happens in very deep sleep, in non-REM sleep, is that there are lots of little channels within the brain that open up, something called the glymphatic system. And this glymphatic system is a little bit like a sewage system. It's where certain substances are removed from the brain. And in non-REM sleep, those channels open up. But if you have limited non-REM sleep, then actually that can reduce the efficacy of this system. And so actually these proteins may actually build up in the brain. So we certainly are acutely aware that there may be strong links between poor sleep, and that encompasses both sleep deprivation and insomnia, and conditions like Alzheimer's disease.
And to finish, based on everything you've learned, what are 3 practical steps that the average person can take tonight to improve their sleep?
Well, I think the first thing is to try and understand your own sleep. So to have a feeling for what your sleep requirement actually is. And the way to do that, as I said, is to work out how much sleep you need in order to go to bed at the same time and wake up at the same time, wake up feeling refreshed and be ready for bed at your habitual bedtime. So that's a really good starting point. If you have difficulty with your sleep or you feel sleepy, you need to try and work out whether or not you've got insomnia or whether you're just sleep deprived. So if you can fall asleep whenever you get into bed, um, and you are sleeping less than, say, 9 hours a night, um, and you're sleepy during the day, then the likelihood is that you're probably sleep deprived for you. There is another alternative explanation, but we'll get on to that. If you are feeling really tired during the day, but you find that when you're in bed at night you can't sleep, then you've probably got insomnia, and therefore you do need to go and have a chat with somebody, whether that be for CBTI or whether there might be an alternative explanation. The third thing is try and work out whether or not you've got a sleep disorder. So the two commonest sleep disorders that we see are sleep apnea. So are you snoring at night? Are you male, which is a big risk factor? Are you overweight? Do you feel tired when you wake up in the morning despite an apparently normal night's sleep? Does your bed partner say that you're stopping breathing at night? If you say yes to any or all of those, then you should definitely be going to see your GP to get a test for sleep apnea, because treating that sleep apnea may transform your life.
Thank you so much for your time, Guy. Really, really appreciate it. That was great.